Hello everybody, so Shazizz here. I want to show you something interesting. Hope you like it and give me a little bit of feedback on it. Tell me what you think. This is a transformer that I chopped up. Remember what it's actually out of. I think it was an old style microwave oven. But these are two primary coils off of a couple of microwave oven cores. And so what I'm going to do here is I'm going to basically build sort of like a flyback driver. I'm going to put these on here like that. And so this will be my center tap right here. And what I'm going to run it with is one of these nifty little servo testers. 30 amp RC motor controller. Sorry about that. So you see it's got 3 wires hanging off of it. Let me get this stuff out of the way here. I'll try to make this as short sweet as possible, but I don't know how it's going to play out. Anyway, so on the center right here, I'm going to hook it to the one where I got the center tap at, where these two coils are going in opposite directions. Then, from that point, I'm going to take these 2 yellow wires. I'm going to connect one to this side and one to that side. Just like that. Alright, now earlier I was running this off of 12 volts and I got some pretty interesting anomalies off of it, but I wasn't videotaping at the time. So what I'm going to do now, I got my power supply right here, which is going to be one of these 9-volt batteries. Alright, so let's take and test that 9-volt battery. Let's see what we get. Alright, that's on DC. And this one here is right about, really, 8.51 volts. This one here, this is about 8.71 volts. Alright, so I'm going to move this one over here. Hang those off to the side for a moment. Try not to tangle everything up there. Alright, so what else I'm going to do here is I'm going to take this bridge rectifier right here, which I don't know if you can even see the numbers on that. Kind of blurry. And an AC capacitor. Okay, that's out of my microwave oven. Okay, now let's start hooking some wires up. So, I'm going to need a positive and a negative off of my output of my bridge rectifier, which on this particular one, positives on this side, negatives on that side. So I'm going to hook my negative up. Come on. And I'm going to hook my positive up. Okay, so I think you can still see this voltmeter right here. So now, a couple more wires, and I'm going to connect a negative, and then to the negative side of the voltmeter, right there. And then I'm going to connect my positive to my positive side of the voltmeter. Alright, looks as though I still got a little bit of voltage left in there for a second. It's down. Alright, so now the output of the bridge rectifier is actually connected to the AC capacitor. So, with that said, I got a couple more wires over here, if I remember right. I'll use the yellow and the... I'll just use the two red ones. Okay. So, before I do anything here, I want to take this and connect it to the what would now be the secondary. So these two here would be the primary, and the bottom coil would be the secondary. And I got this on AC, set around about 200 volts. And so we want to get a voltage reading. So I'm going to connect these two right here to there. Alright. Now I'm going to take my battery. I'm going to connect my positive to my positive and my negative to my negative. Alright, now the little servo tester right here has 3 settings. Oh, come on, man. You're aggravating me. Alright, servo tester has 3 settings on it. It has manual, it has neutral, and it has automatic. So we're going to use the manual side of this right here. And see if I can get that wire there out the way. So you can still see the voltmeter. Alright, hopefully you can see that. Alright, so now I'm gonna adjust this a little bit. And see there just briefly I got let me see if I can get it just right. Alright. Just going to turn it just briefly on there. Okay, so basically it's showing 0 volts out of there. So I'm going to take these other 2 wires from one side of the deal here and then onto the AC side of the rectifier. I'm only using 2 of the prongs on there, but it's alright. And I'm going to do the same thing. I just connect it on there. On the opposite side. Alright. Now, you see that voltage on there. See the voltage output over here. So anyway, I thought this was a little bit interesting because when I started off and I could only get the doggone thing to go up to 0.2 volts, but yet I was able to, if you watch that voltmeter over there, when I get it adjusted just right, and you see the voltage right there. Come on. These little servo testers are a little tricky. Let's leave it right there. Anyway, I'm still measuring the output on this right here. And every so often, depending on where you actually get it, you can get it to show 3, you know, around about 3 volts AC. But I thought that was pretty interesting, to where right now when it's 0.2 over there, fluctuating back from 0.1 to 2 to 3, maintains about 7.5 volts DC coming through that rectifier right there. And when you run this 30 amp one with the 12 volt power supply, it gets hot. This is really cold to the touch right now. So we're not really getting any major output. Let me take and disconnect that and let that capacitor drain down. Okay, it's at 0. Connect it back up. Anyway, give me some thoughts on what you think that's all about. Show you, when I had it hooked to the 12 volt system, you put this neodymium magnet over there, you could actually feel the AC pulse. Right now it's just trying to attract to the metal itself. And let me show you that. I will get that. I will get a different power supply for a second. If I can find it. Alright, this is a little 6 to 12 volt 1 amp battery charger. I'm just going to use it for my power supply if it don't burn everything up, just so I can show you that fluctuation that you get from the doggone deal there. Hopefully it won't get too hot. Alright. Uh-oh. Better turn that up. Hey, look at my voltage up there. That's with the power supply. And so if I take this can see it moving around in my hand when I get it on the right slot. So it's getting a pretty good field. And you also saw the voltage on that right there go up too. So we know the voltmeter's working. So I take this power supply back off. And I'm going to hook it back to the battery. Let that doggone voltage go down over there. Come on. This never wants to cooperate. Alright, so we're down to 0 volts right there. Gradually turning up a little bit. Really? Oh, no wonder. That came loose. Amidst of all that shuffle. Alright, so try to let that drain down. Just gradually turn this thing up. Come on, hit 0. Alright, both of them's on 0. At least it was. And just gradually turn this thing up. So even at 0.2, it's still maintaining 7.4 volts. Let it drain down. Alright, that's good enough. Connect it back up there. Now look at the input voltage as opposed to the output voltage there. Alright, well anyway, I just thought that was interesting, so I'm not doing anything fancy about a video today. I just wanted to share that with you and get your thoughts on it. But I'm going to be doing some things with these little motor controllers here. And I encourage you to go out there and get a couple of those. They're not very expensive at all, and a motor controller, and try different configurations on these this type of transformer right here. Of course, you see I cut off the majority of that core of the old one, and so this isn't even what you would want to classify as you know, efficient. It's junk. It's basically junk. But you see my input voltage right there, or my output voltage from the secondary, and then you see my my output voltage after I rectify that into the AC capacitor down there. So none of which makes any sense, because you know it's an AC capacitor, and you got a DC output on the bridge rectifier right there. But something interesting's happening here. And I imagine that if this was a really nice transformer core with you know, a center tap, you know, just like a regular flyback driver, and you know, had a good secondary on there right there, I imagine you'd probably get some pretty good results. These here run them brushless DC motors, and it's really interesting how they work. They almost work like a flyback driver, and actually use them for flyback driver drivers. And I got an ant crawling down there. But anyway, let me know what you think about that, and if you want to see any more updates on that. But these are the same type of motor controllers, RC motor controllers, that I'm running this gizmo up here with. And I'm running with this smaller one on purpose because I want to show you something cool when it's all said and done. And so in the meantime, I was going to do some experiments with some different transformers to see if how good I could actually pulse the transformer. But I came across this interesting anomaly right here. You can see what's going on. I mean, I could back this thing off, and these things they'll tune to whatever coils you put them to. You can actually hear it like a little musical tone whenever it's doing it with the right power on there. But I'm using just a 9-volt battery. It's not even a strong power source. You see, I almost had one on there for a second, but either way, you can see I'm up to 7.1 volts over there, and it's just kind of barely on right there. I'd like to get it to stay on that 3 there. But it's just these things, like I said, whenever I was doing my my doggone neodymium magnet accelerator, which I'm going to be trying to update when I get my new lab. I'm going to try to update some things on that as well. But these motor controllers, they are pretty cool. That's what I was using to pulse that neodymium magnet accelerator as well. And I've got a large version, big one, for running them paraglider motors. But I wanted to try to see how small of a circuit that I could actually get to run those big motors. And you've seen those motors running off of these before. Now, however, when you're running at 12 volts, these things will get hot. And so as long as you keep them cool, they'll last. But I'm trying to go down as low a voltage as possible and see the least amount of current as possible and the lowest voltage as possible. These things aren't even remotely warm. They're not even getting hot at all. And there's just a tiny bit of current going through there. And you can see on that side over there, there's not much output coming out of that right now. But it's enough to charge that thing AC capacitor up to 7.5 volts. You know, like I said, it's not going to be a fancy video here. It's just something I saw that I wanted to share with you. So if you want to see any more stuff like this, just let me know. Anyway, peace and love, everybody. Take care.